Okay, this is chapter 4.4, factoring polynomials. So the essential question is, how can you factor a polynomial? What you will learn in this chapter section is factoring polynomials and using the factor theorem. Okay, factoring polynomials. Previously, you factored quadratic polynomials. You can also factor polynomials with degrees greater than 2. Some of these polynomials can be factored completely using techniques you have previously learned. A factorable polynomial with integer coefficients is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. Okay, so let's take a look at that in an example. Okay, so here it is, finding a common monomial factor. So this is factoring polynomials. I'm going to do this. I'm going to really break this down and make it basic. And I'm going to write each term vertically. I'm going to do it a little bit different. I'm not going to worry about the signs. I'm just going to write the terms as their absolute values. So these are the three terms we have. Well, x cubed means x times x times x. And 4 is 2 times 2. And x squared is x times x. And 5x is prime, so it's just simply 5 times x. So if you think of this as factoring each of these pieces out, this is called prime factorization. We're factoring all of these down, and then what you want to do is find a common factor among all three. This has a 5. This does not have a 5, so 5 is not a common factor. The second one here has a 2 in it. This does not have a 2. These don't have a, this one doesn't have a 2. 2 is not a common factor. But I do have 1x here. I do have 1x here. And I do have 1x here. So my common factor is x. So if I take that x out, then I'm left with the other components. So let's start in order, x cubed. So how many are left now? 2. So that's x squared. And now you want to be focused on the sign. So I'm going to put a minus here. And I can put these back together. So what's left over here is 2 times 2, which is 4 times x. So that's 4x. And then minus, and the x is gone, but there's still a 5 here. So there it is factored. And x times x squared is x cubed. X times a negative 4x is negative 4x squared. X times a negative 5 is negative 5x. So I'm just doing the distributive property to get back to what I started with. But we might not be done. So I'm going to write my prime factor here, or the greatest common factor, I should say, right here. And then I'm going to see if I can factor this out further. So I'm looking for factors of negative 5 that add up to 4. Okay, so it'd be minus 5 and plus 1. Because x times x is x squared, x times 1 is x, negative 5 times x is negative 5x. Add those two, you get negative 4x. And a negative times a positive is negative. 5 times 1 is 5. So here is x cubed minus 4x squared minus 5x factored completely. 3 factors, x, x minus 5, and x plus 1. Notice what I just said, 3 factors. 3 factors. Okay, so that's how you do this. I wouldn't do this every single time. I just wanted to show you, if you're struggling with this, try doing this prime factorization by factoring everything out completely. Okay, so now I'm going to look at the next one. I look at the coefficient first, 3 and 48. 3 will go into 4 once with a remainder of 1. 3 will go into 18 6 times. So I can factor out a 3. All right, so then I look at the y's, and I want to take the smallest power. Like over here, there was 3 x's in this one, 2 x's in this one, and 1 x in this. So the most you can factor out is the lowest amount, which is 1x. And that's why we took 1x out here. I have 3 y's here. I have 5 over here. So I can take out y to the third. And then that will leave me y to the third. Well, how do I get to y to the fifth? I need 2 more y squareds. So 3y cubed times y squared is 3y to the fifth minus, and that was 16 to get me 48, and y cubed times 1 is y cubed, so it's just this. So now I see I have a difference of squares, which is y plus, so it's a square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. If you remember your factor rules from chapter, what was it, 4.1? So this is now factored completely. 3y cubed times y plus 4 times y minus 4. Okay, so the last one, first I look at the coefficients, 5, 30, and 45. Okay, the lowest of the three is 5, and 5 will go into 30, and 5 will go into 45, so 5 is a common factor. Okay, so then I look at the variables. Z to the fourth, Z to the third, Z squared. The lowest one is the one that is the common factor, so I can take out at most Z squared, 2 Z's from each one. That is going to leave me with, and then all you do now is divide. Let me get the circles out of the way. And you just ask yourself, 5 divided by 5 is 1. You don't need to write 1 as a coefficient. And z to the fourth divided by z squared is z to the 4 minus 2, which is z to the 2. Keep the sign. 30 divided by 5 is 6. Z cubed divided by z squared is z to the 3 minus 2, which is z to the 1. Keep the sign. 45 divided by 5 is 9. Z squared divided by z squared is 1. 9 times 1 is simply 9. So we get 5z squared. And now I'm going to look for factors. And I can factor this because I can see that factors of c will add up to b. So they're all positive. Everything's positive here. And what are factors of 9? Let me just do that off to the side in case it's not clear. 9 is 1 times 9 or 3 times 3. I need the factors of c, which is right here, that add up to b. And b is 6, so I want my 3's. So it's going to be z plus 3, z plus 3. So this factored out is 5z squared times z plus 3 times z plus 3. Okay, so that's how you find common monomial factors. So in this one, the common monomial factor was 5z squared. In this one, the common monomial factor was 3y cubed. And in this one, the common monomial factor was simply x. Okay, so now you should be able to do problems 5, 6, and 8. Okay, so in part B of example 1, a special factoring pattern for the difference of two squares was used to factor the expression completely. So if I go back to that, they're talking about this one here. A difference of perfect squares, y squared minus 16. Y squared is a perfect square, and 16 is a perfect square. Okay, there are also factoring patterns that you can use to factor the sum or difference of two cubes. So the core concept here is special factoring patterns for the sum of two cubes. Now I want to point something out to you in these. They may seem like a lot to remember, but if you have an a cubed plus b cubed, where a is a perfect cube and b is a perfect cube, and you're adding, then the factors are a plus b times the first term squared minus ab plus b squared. So you need a minus sign here, and everything else is plus. When you have the difference of two cubes, the first parentheses is minus, and the AB is positive. That's the only thing that happens is that minus plus switch. So when it's a minus difference of cubes, the first term AB is a minus B. With a cubed plus B cubed, it's a plus B. And here's an example. We have 64x cubed plus 1. So let me just talk about this real quick. If in this case, 64x cubed is our A, and 1 is B. So the rule says take a plus b. Actually, this is a cubed. Let me put the cube up there, my fault. A cubed, and this is b cubed. So you want to take the cube root of these. Well, what is the cube root of 64? Well, the cube root of 64 is 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. So here's our factor tree for 64. And when your index is 3, you need 3 numbers out underneath the radical to equal 1 outside. So I have 2 sets of 3. So that would mean 2 times 2, or 4. So the cube root of 64 is 4. 4 times 4 is 16, times 4 is 64. Okay? So that's how you find perfect cubes, or that's how you simplify a radical as well. That was a review. So I know that my cube root of 64 is 4, and my cube root of x cubed is simply x. So my a is 4x. My b is going to be the cube root of 1. Well, if I take the cubed root of 1, that just means what times itself 3 times equals 1. Well, 1 times 1 times 1 is equal to 1. So my b is 1. So it says to take a plus b. So it's 4x. Okay. So here's how they showed this. They broke that up and said, well, what is cubed here? Well, it's the 4x. So actually what they're doing is finding a here for you as well. I did it down here to explain where this came from. So now we're going to apply it to this rule. So we're at a. A is 4x. So 4x went right here. Plus b, which is 1, which is right here. And then a new parentheses. So now we're at a squared, and a squared would be 4x squared, which is 16, 4 squared x squared, which is 16x squared. Make sure you have that minus sign here, and a times b. Well, 4x times 1 is 4x, so that's done. Make sure you have a plus sign, and then b squared. Well, if b is 1, 1 squared is still 1. So there's the example there. All right, so that's how you do this. And now let's take a look at the subtraction one. So 27x cubed, well, what's the cube root of 27? It's 3. What's the cube root of x cubed? X. So first you break it down and tell in parentheses what x cubed is, minus, and the cube root of 8 is 2, because 2 times 2 is 4, times 2 is 8. So 2 cubed. So this is our a, and this is our b. So you take a minus b, which is 2, parentheses, a squared. So what's 3x squared? It's 3 squared x squared, which is 9x squared. All right, so that's that. Plus, so the plus sign is put down, and then a times b. Well, 3x times 2 is 6x. Okay, and then plus, and then b squared. Well, 2 squared is 4. So that's how you do these. This is the core concept for special factors. This is the sum of cubes and the difference of cubes. Okay, so example 2, we're going to be factoring the sum or difference of 2 cubes. And I want to factor a, x cubed minus 25. So the first thing you do is write the problem, x cubed minus 25. I want to rewrite that as something cubed. Well, it's obviously just x by itself, so it's going to be x cubed minus, well, what's the cube root of 25? I'm sorry, 125. 125. Cube root of 125 is 5, because 5 times 5 is 25, times 5 is 125. So I found out what x cubed is, and I found out the b, which is being cubed. So in other words, what we do when we do that is we're finding a and b in our parentheses. And then we write the formula. I'm just going to write the formula now till you learn it. You should write it every time. X minus, a minus b. A minus b. So the sign is the same in the first parentheses, a squared. And since this is minus, this is plus, they always are opposite. And then it's a times b plus b squared. This is always plus, and these two flip depending on what this sign is. If this is minus, the first one's negative. If this is positive, the first one's positive. So this is the rule, and now I'm going to substitute in my a's and my b's. So a is x minus b, which is 5. So there's my first factor. A is x, so that's x squared, plus ab, well, that's x5. So I'm just going to show it first, x times 5, plus b, which is 5, squared. So this is going to simplify to x minus 5 times x squared plus 5x plus 25. Okay, and you should always check to see if this will factor further. And factors of 25 that add up to 5 does not happen, because you have 25 times 1, which adds up to 26, and 5 times 5, which adds up to 10. So we're done. This is the answer. So x cubed minus 125 equals x minus 5 times x squared plus 5x plus 25. Now we're going to do part B. First, write the problem. 16 s to the 5th plus 54 s squared. Okay, so I look at 16 and I look at 54, and I don't have a cube here and here. The s's are not cubed. So the first thing you want to do is GCF, greatest common factor. 16 will not go into 54. 8 will go into 16 twice, but 8 will not go into 54. 4 will go into 16 4 times. 4 will not go into 54. 2 will go into 16 8 times. 2 will go into 54 27 times. So 2 is my greatest common factor of my coefficients. I have s to the 5. I have s squared. You take the smaller of the two. So my greatest common factor of this is 2s squared. When I factor that out, 16 divided by 2 is 8. S to the 5th divided by s squared is s cubed, plus 54 divided by 2 is 27, and s squared divided by s squared is 1. So there is my first thing I do, is factor out a GCF. This now comes along for the ride. And what I want to do is factor this. So it's 2s squared times, and let me use a bracket here because it's going to be a parentheses inside a parentheses. So I'm going to put a bracket here. And I want to factor this. So it's going to be, here's our first term. Well, what's the cube root of 8? It's 2. What's the cube root of s to the 3rd? S. So you write 2s to the 3rd power plus 27. The cube root of 27 is 3 to the 3rd power. So what I just found here is my a, which is 2s, and my b, which is 3. All right, so then we'd say, okay, well then that is 2s squared times, and remember it's a minus, in this case it is the sum of cubes, so it's going to be plus, so I'm going to write that first. We have an a plus b times a squared minus, because these signs are always opposite, a times b, and it's always plus b squared at the end for both of them. Okay, so there's our rule, and now we're just going to substitute. 2s squared, a is 2s, plus b, which is 3, so it's 2s plus 3, times a squared, which is 2, and let me do it this way. It's 2s squared minus, I'm just going to show all my work, a, which is 2s, times b, which is 3, plus 3 squared. Okay, so now we simplify and we'll be done. 2s squared times 2s plus 3 times 2 squared, which is 4, s squared is s squared, minus 2s times 3, which is 6s, plus 3 squared, which is 9. Factors of 9 that add up to 6 are 3 and 3, but we have this 4 over here. So at this point, we're just going to leave it like this. So we have 2s squared times 2s plus 3 times 4s squared minus 6s plus 9. So there is factoring 2 cubes completely. Okay, so now you should be able to do problem numbers 13, 14, and 16 in your exercise. Okay, for some polynomials, you can factor by grouping. It's called factor by grouping. Pairs of terms that have a common monomial factor. The pattern for factoring by grouping is shown below. So they gave a basic, very basic example. RA plus RB plus SA plus SB is what was given. So in this one here, actually let me do it in red. RA plus RB has a common factor of R. So they factored out an R. SA plus SB has a common factor of S. So they factored out an S. So this here factors out to R times A plus B, and this factors out to S times A plus B. Factoring is the inverse of the distributive property. And then when you do that, these two parentheses are the same. And so then we can factor out an A plus B from R plus A plus B plus S plus times A plus B. So now we're just factoring it again by grouping. Let me just get rid of all this. So what you have is an A plus B like term that you can factor out, and that would be R plus S times A plus B. So if I distributed this, R times A plus B is right here, and S times A plus B is right here. Okay, so it's just prime factorization, or factoring out like terms twice, basically. So let's take a look at that in the next example. Okay, example 3, factoring by grouping. Factor z cubed plus 5z squared minus 4z minus 20 completely. So what you want to do is focus on the first two terms and the last two terms and look for common factors. So in z cubed plus 5z squared, I can factor out the lowest power of the two, which is z squared. That would leave behind z cubed divided by z squared is z, plus 5z squared divided by z squared is 5. Now when I go to this one, I can factor out a negative 4. So I'm going to put minus 4. Careful with your signs. Negative 4 will go into 20. 4 goes into 4, so that's our common factor. It has a z here, but this does not have a z, so z is not a common factor. So I factor out a negative 4, and negative 4 times z equals negative 4z, and negative 4 plus 5 is going to give me negative 20. So notice I have a z plus 5 and a z plus 5. So what you do is you take the terms that are outside. Z squared minus 4 is one term, and z plus 5 is the other. Okay, so it's z squared minus 4 times z plus 5, but I'm not done. Z squared is a perfect square, 4 is a perfect square, and it's minus, so that's the difference of squares. And the difference of squares is the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. And then this z plus 5 comes down for the ride. Okay, so this factored completely is z plus 2, z minus 2, and z plus 5. Now keep in mind why we are factoring. if we wanted to graph this, we just found the solutions to this function. We found three solutions, or three zeros, and it'd be z equals -2, z equals +2, and z equals -5. Those are the three x-intercepts. Okay, so that is the reason for factoring these polynomials. And so try to do this on problems 23, 24, and 26. Okay, so hopefully you're getting a feel for this factoring thing. You always should try to factor out a greatest common factor first. GCF is always the first step. And because I don't see that this is a difference of perfect cubes, because there's a 4 here. This is a perfect cube, but is 16. 2 times 2 is 4, times 2 is 8, 3 times 3 is 9, times 3 is 27. So that's not a perfect cube. And obviously x to the 4th is not a perfect cube, because it'd be a degree of multiples of 3. 81 is a perfect cube. No, it's not. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. 5 times 5 cubed is 125. So this is not a perfect cube either. So we're trying to find what we can factor out of this. Well, if it's a power of even factors, it could be a perfect square. And that's what this appears to be. So I look at that and I say, okay, this is a difference of perfect squares. So what's the square root of 16? 4. What's the square root of x to the 4th? X squared. So I have 4x squared squared. Because if I distribute that, 4 squared 16, x squared squared is x to the 2 times 2. That's the power rule of exponents. And that's x to the 4th minus, and the square root of 81 is 9. So it's -9 squared. So this is the difference of squares. And the difference of squares says take a plus b times a minus b, where a and b are the square roots. Okay, so I'm going to, this is my a and this is my b. So it's going to be 4x squared plus 9 times 4x squared minus 9. Okay, so this is not a, there's no such thing as the sum of squares, but there is such thing as a difference of squares. So is this a perfect square? Is this and is this? And the answer is yes, and there's a minus sign. So it's a difference of perfect squares within the factors of a difference of perfect squares. So sometimes you have to do it twice. So this 4x squared plus 9 is done being factored. 4 won't go into 9. There's no such thing as a sum of squares. And then we take the square root of 4 and the square root of x. So you take the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Whew. Okay, so 2x plus 3 is linear, 2x minus 3 is linear. I can't factor anything out of those. This is factored. So this is the answer. Okay, 4x squared plus 9 times 2x plus 3 times 2x minus 3. So if we wanted to know where this thing is crossing the x-axis, we would solve these and find out the x-intercepts. One is -3/2, one is +3/2, and this would be the square root of 9/4, which is 3/2 as well, okay, and -3/2. Okay, so that's A factored. Now let's take a look at B. We have 3p to the 8th power plus 15p to the 5th. So as I'm doing this, I'm thinking, will 3 go into 15? And the answer is yes. So 3 could be a common factor. And we have powers of p. So those could be common factors as well. And then 18, and I ask myself as I'm writing this, does 3 go into 18? And it does. And we have more p's on the last term. So there's 1, 3 here. So that's the most you can factor out. And we have p to the 8, p to the 5, p to the 2, and you can always factor out the least power of the 3. So the greatest common factor of this trinomial is 3p squared. Then you put parentheses and just divide. 3 divided by 3 is 1, p to the 8 divided by p squared is p to the 6th, plus 15 divided by 3 is 5, p to the 5th divided by p squared is p cubed, plus 18 divided by 3 is 6, p squared divided by p squared is 1. So now I've factored out a greatest common factor, and now I have p to the 6 plus 5p cubed plus 6. Okay, so then I ask myself, well, are there factors of 6 that will add up to 5? So off to the side here, 6 is 1 times 6. 6 is 2 times 3. Everything's positive, so those are the only two factors. So if I take 1 plus 6, I get 7. If I take 2 plus 3, I get 5. And my b is 5, so I want my 2 plus 3. So I take 3p squared times p to the 3rd, p to the 3rd. P cubed times p cubed is p to the 3 plus 3, which is p to the 6. There's my first term. And then I put these two numbers here, plus 2 plus 3. Because when I FOIL, L would be 2 times 3, which is 6. And first is p cubed times p cubed, which is p to the 6th. Outer is 3p cubed, inner is 2p cubed, and they add up to 5p cubed. Okay, so this is a cubic, this is prime, this is a cubed, this is prime, this is a squared. There is nothing else I can do. This is 3p to the 8 plus 15p to the 5th plus 18p squared factored completely. Okay, so now try numbers 31, 32, and 34. Okay, the factor theorem. When dividing polynomials in the previous section, the examples had non-zero remainders. Suppose the remainder is 0, where a polynomial f of x is divided by x minus k. Then we would have the function f of x divided by x minus k equals the quotient function q of x plus 0 over x minus k, which is just simply q of x. So where q of x is the quotient polynomial, therefore f of x equals x minus k times q of x. Okay, so let's just stop right there. And what are they talking about here? All right, so f of x equals x minus k times q of x. F of x equals x minus k times q of x. So that x minus k is a factor of f of x. The result is summarized by the factor theorem, which is a special case of the remainder theorem. So what are they trying to say here? F of x equals. So in other words, they're taking f of x over x minus k and saying that since this is 0 over x minus k, this cancels, leaving us with just q of x. So that's where this, so then we would have f of x over x minus k equals q of x when there's no remainder. But if I want to get f of x by itself, I multiply both sides by x minus k because that's the denominator. Okay, and when I do that, this is 1, leaving us with f of x equals x minus k times q of x. Okay, so that's what they're saying here. So that would mean that x minus k is a factor of the original function. The result is summarized by the factor theorem, which is a special case of the remainder theorem. If there are no remainders, then it is a factor. Okay, so the core concept basically states the factor theorem. A polynomial f of x has a factor of x minus k if and only if f of k equals 0. In other words, x minus k is a factor of f of x if and only if k is a 0 of f, or a solution to the function, in other words. So what they're trying to say here is, if I had a function f of x and its factor was, say, x minus 4, then that would mean that when you did f of 4, you would get 0. That's all that's saying. So it's basically just saying whatever you have in the parentheses, the 0, the opposite 4 would make the function 0. That is a solution or x-intercept of the function. Okay, so example 5 says determine whether a linear binomial is a factor. Determine whether a x minus 2 is a factor of f of x equals, so I'm going to write this. This is a f of x equals x squared plus 2x minus 4. So you can do direct substitution first. So here's our x minus k. It says it's a factor if and only if k, f of k is 0. So x minus 2, k is 2. So I want to check and do direct substitution into my function and do f of 2, which is 2 squared plus 2 times 2 minus 4. And f of 2 simplified would become 4 plus 4 minus 4. So f of 2 equals 8 minus 4, which is 4, and that does not equal 0. So x minus 2 is not a factor. Okay, so that's one way to do it. The other way you can do it is by synthetic division. So I'm going to continue I'm going to do it again with synthetic division. So if I have x minus 2, k is 2, which would mean I'd put a 2 here and draw this and put my leading coefficients of 1, 2, and negative 4 right here. Bring down your first term. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 4 plus 8 is 4. And there is our remainder. That is not 0. So therefore, we can state the same reason. Okay, so now let's take a look at B. B says, is x plus 5 a factor of this? So the first thing I'm going to do is write f of x equals 3x to the 4th plus 15x cubed minus x squared plus 25. Now I can do direct substitution here, but in this case, x plus 5, that would mean x minus a negative 5 gives me x plus 5. So this is my k. It's always the opposite of this sign. So I would do f of negative 5 equals 3 times negative 5 to the 4th power plus 15 times negative 5 cubed minus negative 5 squared plus 25. Okay, so substitute that in, simplify. 5 times 5 is 25, times 5 is 125, times 5 is 625. So that is a negative 625, and I need to multiply that by 3. 5 times 3 is 15, 3 times 2 is 6, plus 1 is 7, 6 times 3 is 18. So it's 1,875, negative 1,875. Now I'm doing this to show you something. I'm doing this for a reason. 5 cubed is 125, negative 125 times 15 is 5 times 5 is 25, 5 times 2 is 10, plus 2 is 12, 5 times 1 is 5, plus 1 is 6, 0, 5, 2, 1, add, and I get negative times a positive, which is negative 1875 again, minus, or let me make sure this is right, a negative, oh, I'm sorry, right here, a negative to the 4th power is not negative. This would be positive. It's not negative 625, it's positive. so it's not a negative in front, okay? Negative to the fourth power is positive, times 3 is positive. This came out to be 1,875 minus 1,875, and this is negative 5 squared, which is 25, and so it's minus 25 plus 25. Well, 1,875 minus 1,875 is 0. 0 minus 25 is negative 25 plus 25. So that does mean that f of negative 5 equals 0. That tells us that x plus 5 is a factor of f of x. Okay, now this was a lot of calculating, and without a calculator, I had to actually do long multiplication off to the side. But now I'm going to redo this problem using synthetic division. So remember, our k is negative 5. So you write negative 5. Draw this leading coefficient 3 plus 15 minus 1. And don't forget your spacer. There's no x, 0. And then my constant 25. Don't forget that 0 because there's no x to the first power. 4, 3, 2, 0. You have to put a 1 in. Bring down your first term. Negative 15 times 3 is negative 15. 15 plus a negative 15 is 0. Negative 5 times 0 is 0. Negative 1 plus 0 is negative 1. 5 times 1 is 5. Negative times negative is positive. Bring that down 5. Negative 5 times 5 is negative 25. Add them and you get 0. Which would you rather do? Okay, when you get a 0 as a factor, or when you get a 0 as a remainder, then what you divided by is a factor. Okay, so now you should be able to do 39, 40, and 42, and may I suggest using synthetic division? It is much easier. Okay, example 6 says to factor a polynomial. Show that x plus 3 is a factor of f of x, then factor f of x completely. Okay, so I want to show that that's a factor of f of x. It's the easiest way is to do synthetic division. My k is negative 3. So I write negative 3. And I draw my synthetic division chart. And 4, 3, there is no x squared, so don't forget that. 1, 0. 4, 3, 1, 0. I need a 0 for the 2 position. So my leading coefficient is 1. My second coefficient is 3. And my x squared's not there, so I'm going to put a 0. My next one is negative 1, and my last one is negative 3. So these are the coefficients for f of x. Bring down your first term. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. Negative 3 times 0 is 0. 0 plus 0 is 0. Negative 3 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 3 times a negative 1 is a positive 3, and negative 3 plus 3 is 0. Okay, so if you don't remember, this would be constant first, second, third. So that would be x cubed plus 0x squared plus 0x minus 1. This is what we got when we divided this by x plus 3. So I could write it like this, just to tie this all together. And this is a difference of cubes. And then I can say, okay, well, that's a difference of cubes. So that's x minus the square root of the first term minus the square root of the second term times the first term squared plus a times b, which is x times 1, which is just x, and then b squared, which is plus 1. Factors 1 that out to 1, no such thing. So we're done. So it's x plus 3 times x minus 1 times x squared plus x plus 1. These are all the factors of this polynomial. Okay, so I went further than I had to. I just wanted to show that x plus 3 is a factor, and since my remainder was 0, then the factor theorem says that x plus 3 is a factor. Okay, it says then factor completely. So there it is. I factored it completely. Okay, x plus 3, x minus 1, x squared plus x plus 1. All right, so now you should be able to do problem numbers 45, 46, and 48. Okay, this is a really neat problem. It says example 7, real life application. During the first 5 seconds of a roller coaster ride, the function h of t is 4t cubed minus 21t squared plus 9t plus 34. And it represents the height h in feet of the roller coaster after t seconds. How long is the roller coaster at or below ground level in the first 5 seconds? So we have to make sense of the problem first. So here is the 0 second mark. So they're starting above ground, obviously, and then they go down, and right here is ground level. That's height 0. They're underground from there to here, and then they're at ground level again, and then they come up above ground. So I want to know, the question wants to know, how long are they underground? So this appears to be 2, 0. And this point is right on a corner. That appears to be -1, 0. So those are 2 of our x-intercepts. And then this one here is more than 4, but less than 5. So it's 4 point something, or a fraction, 0. I don't know this value, but I can find it. So first thing we want to do is assume that these are exact and check. So if this is -1, then my k that's my k. So I'm going to write -1, and that's what I'm going to divide by. And my leading coefficient is 4, and it goes 3, 2, 1, 0. Nothing gets skipped. I don't need any zeros. I'm going to write -21 plus 9 plus 34. Okay, actually, I don't need the plus signs. I don't know why I wrote those. It's just positive. Don't put pluses in front of all the positives. All right, and then we're going to bring down our first term. -1 times 4 is -4. -21 plus a -4 is -25. -1 times a -25 is 25. 25 plus 9 is 34. -1 times 34 is -34, and I got 0. That tells me that that is a factor. So that is indeed, I just have confirmed that -1, 0 is a solution or a factor. -1 or t plus 1 is a factor. Okay, did you catch that? The factor is the opposite. So now, since we're in terms of t, I know that one factor is t plus 1. Okay, now I'm going to check the second one. So it is 2. My k is 2. So I put 2 and do my synthetic division thingy with 4, -21, 9, 34. Bring down your first term. 2 times 4 is 8. -21 plus 8 is -13. 2 times -13 is -26. Is that right? 4, -21, 9, 34. 2 times 4 is 8. 21, -13. 2 times -13 is -26. 9 minus 26 is -17. -17 times 2 is a -34. Okay, it's all correct. I was just starting to question myself there, but it all came out good. That is proof that that is a solution. So if 2, 0 is a solution, then the factor is t minus 2. Okay, the opposite of what you divided by. So now I have t plus 1 as a factor, t plus 2, or t minus 2 as a factor, and then I have a third factor, which is t minus whatever this value is here. Okay, so what's really neat about this is T times T is T squared. T squared times T is T cubed, but I need a 4. So now I know that this isn't just a T, it's 4T. Okay, let me go over that again. T times 4T is 4T cubed. Okay, so that's what told me that this leading coefficient is 4. And I have a positive times a negative, which is negative. And I want a positive at the end, so that's got to be negative. So a positive times a negative is negative. A negative times a negative is positive. So that tells me this sign right here. Okay. And then I have 1 times a negative 2, which is negative 2 times something equals 34. Well, 34 times 17, or 2 times 17 is 34. So now I figured out the last factor. And so now I know that my 0 is negative 1, negative 2, or 2. So this is 2. And this would be using the zero product property. These all have to equal 0. Remember, that's the ground level. So now I take 4t minus 17 equals 0. Add 17 to both sides, and I get 4t equals 17. Divide by 4, and t goes into 17. 4 times 4 is 16, and 1/17. Okay, so then I could just get my calculator and say, okay, what is 1 divided by 17 if you don't want a fraction? And it's 4.0588. Okay. Okay, I'm making it more difficult with this. I don't want to do that with that fraction. Don't make it a mixed fraction. Just think of it as 17 quarters. Okay. All right, so that makes it much easier because 4 quarters is 16 and a quarter. So this is actually 4 and a quarter. Not 4 and 1/17. I made a mistake there. It's 4 and a quarter. So the roller coaster was underground from 2 seconds to 4 and a quarter seconds. So if you take 4.25 seconds minus 2 seconds, then you get 2 and a quarter seconds. It was underground in the first 5 seconds of the ride. Okay, so that's how you do this problem. So that was kind of a neat problem. So now you should be able to do problem number 55. Okay, that brings us to the end of chapter 4.4. Please do these exercises if you haven't already, and have a great day.